welcome. Today in this session we will talk on the lecture 2 on the introductory part. In this we will talk on elements and features of protection scheme. Specifically we will address on the functionalities of different elements in the protection scheme, different relaying principles and their features on different protection schemes. So, we know the usage of fuse. We use in our house wiring also. So, whenever there is a fault or a short circuit in the circuit, then the current becomes high and the fuse is blown out. So, in that case the faulted path becomes isolated from the rest and the rest of the circuit remains intact. Repair the faulted portion and then replace the fuse, that circuit also can be restored. Now, fuse is very comprehensive and easy to and a very cost effective solution for protection, but it has limitation in terms of current interrupting capability and therefore, it is not suitable for high voltage applications. In that case, circuit breaker and relays are being used. The task of circuit breaker is to isolate the circuit. It provides a physical isolation of the faulted circuit. Relay makes the command to the circuit breaker to be open as and when required. Come to this circuit, two buses connected through a transmission line and this line is to be protected by this protection arrangement. Here we have the circuit breakers which is to be open in case of a fault in this line at any point in the line. This circuit breaker is being actuated by this relay. The relay takes signals of the system through this sensor and the relay and the circuit breaker is being actuated by this battery. The battery provides the required power to this such the arrangement. Going into details of this circuit, if you see here, this relay takes signals from the voltage transformer, otherwise called also potential transformer, and also current transformer. So, using these signals, this relay makes a decision, yes there is a fault in this line or not, and based on the decision, if the decision is a trip decision, then this path will be closed. So, once that is so, the battery supplies the corresponding current to the trip coil and the trip coil opens the circuit breaker and thereby the corresponding fault can be successfully intervened. In this arrangement, we see that there are two important components, the relay and the circuit breaker. The relay takes time for a decision, actuates the circuit breaker and the circuit breaker opens. So, in terms of time, we have two aspects, relay decision time and the circuit breaker opening time. So, therefore, the time for fault clearing from fault inception till the clearance of the fault clearing time, that equals to relay decision time plus the circuit breaker opening time. So, for a faster decision, we can by faster decision we can clear the fault early. If the circuit breaker also can intervene the fault at earlier, then also we can have the advantage of the clearing the fault early. Now, come to an example on this aspect. So, in a system there is a phase B to ground fault and a relay records the event, numerical relay. Say in this you can say that case U 1, U 2 and U 3 are the voltages for the R, Y, B phases, I 1, I 2, I 3 are the corresponding currents. Now, if you see these plots, then this I 1, I 2 and the I 3 the corresponding, let us say this is phase B plot. So, for phase B current you see here you can say that this current suddenly jumps up to a very high magnitude. This means that this is the inception of the fault and the fault continues. Now, this you see here the relay now trips. So, this trip signal of the relay is being actuated here. So, it becomes high if you see here, and from the fault inception to the trip signal you see this time elapsed, you can say that is 26 millisecond. So, the relay decision time from fault inceptions to the trip signal generation comes out to be 26 millisecond here. This is a 50 hertz system application. Now, following the trip signal the circuit breaker starts opening and after some time it successfully intervenes the fault. So, you see here in that phase B where the fault current was high, now suddenly comes out to be 0. The fault is successfully intervened. Now, following that you see here in the phase voltages also, the voltages also comes out to be 0. So, therefore, the circuit breaker has successfully isolated the faulted part. So, this fault means the trip circuit relay trip command till the circuit breaker opening, this is nothing but the circuit breaker opening time, and that is why I can say that in this case this comes out to be 70 millisecond time. So, in total we see that fault inception till the opening of the circuit breaker successfully, this total time is nothing but fault clearance time, and the fault clearance time in this case comes out to be 26 millisecond for the relay decision time and 70 millisecond for the circuit breaker opening time, total is 96 millisecond. This 96 millisecond for the 50 hertz system, each cycle 20 millisecond, 5 cycles corresponds to 100 millisecond. So, it is comes out to be less than 5 cycle period of time. So, we see that in this case that the fault clearing time is controlled by the relay decision time and the circuit breaker opening time. Circuit breaker gives us physical isolation, mechanical functioning actuated by the relay. So, that takes 2-3 cycles and the rest period you can say that in general it taken by the relay decision time. Going more into this protection scheme, we have relay, we have breaker, we have the relay actuated by the DC supply, we have sensors, voltage transformers and the current transformers. In addition to that, today numerical relays are having a facility to communicate the information to other relays or any substation devices, or they can also receive information from other relays also to have a better decision making for the protection. So, this communication helps in total system protections perspective much better, and that is why the decision process becomes more improved one. The different communication facilities that can be incorporated in such a protection scheme can be dedicated fiber optic, can be telephone line, and also can be a power line carrier communication based approach also. So, we say that there are different elements in a protection schemes like relays, breaker, sensors, communication channel, DC supply systems, and the control cables connecting to such devices in a protection scheme. The instrument transformers or the sensors, basically we have two types, the current transformers and the voltage transformer. Current transformer scale down the current to a suitable level, because relay is a small signal device to make it more cost effective, and this provides, you can say that, a magnetic isolation from the high voltage system. Voltage transformer similar to that, scale down the voltage to a lower voltage level suitable to the compatible to the relay, and then also you can say that a galvanic isolation is being provided by this VT from the high voltage system. The different functionalities of these elements in the protection system: the relay detects the fault, makes a decision, triggers the trip circuit which commands the circuit breaker. It can store information on the fault aspect, voltage, current, sample sensor, and it can have a reporting which can be very useful for the fault diagnosis and further analysis following a fault. It can continuously monitor voltage, current and other things, which can be also useful in metering purpose also. Similarly, circuit breaker functionalities: circuit breaker interrupts the faulted path successfully, where current can be very high during that period of time. It isolates the faulted section, it provides a physical isolation. So, thereby I can say that the damage and the safety perspective are can be addressed. Circuit breaker needs to be reconnected to restore that line after the fault being cleared. So, circuit breakers makes and breaks a circuit. There are different types of circuit breakers available, like air brake, SF6 or sulfur hexafluoride circuit breaker, vacuum circuit breaker, depending upon the medium of insulation. However, in this course we will only confine to protective relays and its different applications, application perspective. These you can say that elements combinedly provide a protection scheme. A protection scheme has different features which need to be looked into for a reliable operation of the protection scheme. The first important point is reliability. It must be reliable, the protection scheme must be reliable, otherwise at times it may fail, which implies a dangerous situation and which lead to, you can say that, destructive destruction in a system. It should be accurate. Say a protection scheme for a one line takes a decision for a fault in another line. So, that is a malfunction situation, inaccurate or improper, you can say that, decision situation. So, that is undesirable. So, therefore, a protection system should be as accurate as possible. Fastness, speed is essential, otherwise may lead to damage. Any system, any element may fail at times. So, a protection scheme for a power system may also fail. So, in that case you can say that the arrangement, the whole protection scheme should have a backup arrangement also. Power system is dynamic, system condition changes always. the relay should adapt to that system condition, and during all such situations also it should function accurately, properly, reliably. Today's numerical relays have this capability of recording data for further analysis. It can integrate other relays in the system or in the substation through dedicated communication system. A relay should draw minimum power from the battery. The burden to these sensors CTs and PT should be as low as possible, otherwise it will be a lossy system. As compared to the system cost, power system cost, the cost of the protection scheme is concerned from implementation point of view. Relay engineers also are concerned about maintenance of such protection scheme, calibration, setting aspect. It should be as simple as possible. Technology changes, and with numerical technology, computer based technology is changing very fast. So, the life cycle of the relay is a concern for the decision on the protection schemes to be implemented for an application in power system. Relay should be reliable. Reliable implies two aspects. First one is on dependability. It is a measure of certainty that a relay operates for all faults for which it is designed. That implies that whenever a fault is there in a line, the corresponding relay must take a decision. Otherwise, the fault will continue, which will be detrimental. The other aspect is that security is the measure of certainty that the relay will not operate otherwise. The relay which is protecting a line should not operate for during normal loading condition, or if the fault is beyond the line. So, it means that the say for example, to clarify on this, a 2 ampere load is there, full load, a device load draws 2 ampere full load current, and we have two ratings of fuse 3 ampere or 5 ampere. Now, we have to select out of these two. Say for 3 ampere, if we select 3 ampere, yes, for this load any fault happens to be there, the fuse will take care. But if there will be a momentary overload in this circuit, then there is a chance that this 3 ampere fuse will be blown out, which is undesirable. Now, if you select 5 ampere, that undesirable tripping for overload can be avoided better way. But with 5 ampere, many faults which will having a lesser amount of current, not significant amount of current, may not be detected and fuse may not be blown out. So, that becomes a challenging. So, in this perspective, when you pick up 3 ampere, it is more dependable, dependability is high, but security is less. When you pick up 5 ampere, security is high, dependability is low. But reliability is a combination of dependability and security. In general, protection schemes are more inclined towards dependability. However, with today's numerical technology, the overall reliability can be enhanced, and when you make a decision on which protection scheme is to be incorporated in a system, the reliability is one of the important aspects on the decision process. Now, on other aspects of protection scheme, let us see this circuit. Substation source, we have two sections of line, and let us say consider a fault happens to be at point F. Now, in this case there is a clear mandate here that the relay R 2 should make a decision and trip the breaker here. So, that this section can be isolated and the rest of the portions including this load can be made from the substation. So, it means that however, at this for the fault at F, the current through this R 1 and R 2 will be both same. So, therefore, you can say that it becomes a challenge to R 1 and R 2 that which one should act first. But as you see, the requirement is that R 2 should act first for this case before the R 1. So, there is a perspective we call selectivity required bit that so that the faulted element is isolated successfully and also reliably. So, this selectivity you can say that is an important factor, and this is being you can say that addressed by different features of a protection scheme. Magnitude of current when the line sections becomes longer, then faults in different sections can be easily identified from the magnitude of current. But if the line section becomes smaller like this here 1 kilometer here 1.5 kilometer here, fault at in this section or fault in these sections will lead to similar level of current. So, therefore, you can say that distinction through simple magnitude may not be possible. Faults can be discriminated also, whether the fault is to the left or to the right, or we call it upstream or downstream, and that can be done through fault direction or through the directional relay. There is another option also that time grading in case of overcurrent link principle also, that the relay R 2 should here for this fault should act fast as compared to the relay R 1. So, you can have you can say that time grading principle embedded into the relay process, then you can have a better selectivity solutions in that perspective. The other things that see this circuit here, we have a transformer connecting to a source or the substation, and then we have a line section. If this fault happens to be close to the transformer and we have a relay protecting the transformer at R, then the relay only simply from the overcurrent principle may not be able to distinguish whether the fault is in the inside the transformer or beyond the transformer. So, that means that we require more different principles to have you can say better protection for the different elements, and in this case for transformer a better protection scheme can be a differential relay principle using sensors at both the sides of the element. So, what you see that different elements and different systems may be requiring different relaying principles, and the behavior the fault behavior of different elements in the systems may be different, and their functionality may be different. So, therefore, you need different relaying principle for better protection of the power system elements. In this perspective, we have numerous relaying principles available, and based on that we have different relay available: time overcurrent relay, instantaneous overcurrent relay, directional overcurrent relay, distance relay, differential relay, frequency relay, under frequency relay, under frequency relaying, and so many others. These relays are we can say that having a device number like here 51 for time overcurrent relay and 50 for instantaneous overcurrent relay, 21 for distance relay, and so these are in terms of IEEE standard, and they are being widely used by the protection engineers. We have different areas sections allocated to different protection scheme, like the generator portion is being protected by an arrangement of the protection, the transformer being protected by another one, and the zone this line section they can be protected by different protection schemes. So, these are divided into, they are called, you can say that, different zones, but note that you can say that these zones must be overlapping, because not an inch of the section in the power system should be left out, you can say that, from the protection. Otherwise, if a fault happens to be there, the fault will continue and that will be detrimental to the system. In this perspective, the different zones can be classified into two categories, closed type or open type. Closed type is having sensors at both the ends like differential relay, and they are also otherwise called also unit protection scheme. Non-unit protection type, where you can say that we have or otherwise called also open type, open zone, you can say that perspective. They can have sensors at only one side, like the applications of relaying principle applications to overcurrent and distance relay. Now, see this network, source or substation fitting to that two sections and a fault in the second line. So, in this case, now for this R2 relay should actuate the breaker. Now, let us think of a situation when the relay fails R2 or the breaker fails to open, or the communication between R2 and the breaker or the battery, you can say that, supply fails at this point. That means that the fault will continue and that will be, you can say that, will lead to damage in the system and issue with the life security and so. So, therefore, in this case, in case of a failure of any protection schemes, there must be a backup. So, in this case we say R2, you can say that for this fault R2 you can say that is the primary, and the backup should be, you can say that, should be provided by this R1 and the corresponding circuit breaker arrangement perspective. The other functions which are available in protection schemes, like see here in this example, we have a fault in this lateral, and then we have a reclosure arrangement. Now, what the reclosure does is that because in an overall line most of the faults are transitory in nature, they remain for some time and they vanish. So, therefore, the reclosure what it does, that whenever it finds a fault, it opens and again recloses after some time. So, thereby by that time if the corresponding fault has vanished, so the whole system supply can be restored automatically. So, this kind of trials it makes 2-3 times, and if that by that time the fault has vanished, then the system is being completely restored. Now, if the fault is permanent, then the closure, you can say that, finally opens the circuit and thereby whole system can be without supply. The advantage of the reclosure is that because most of the faults are transitory in nature, so therefore, the restoration becomes automatic in most of the cases, and the also it helps in stability issue. But the reclosure is meaningful, purposeful, because most of the transitory faults are single to line guard faults, but if fault happens to be 3-phase faults, then they are mostly permanent. So, therefore, the reclosure should able to distinguish these two. Further, in case of cable faults are permanent in nature. So, reclosure should not be used in that case. The other, you can say that things, let us say this fault being permanent, and in that case the reclosure opens, then whole, you can say that network supply is being affected. Now, what we see here, if the fault is permanent and if we add a sectionalizer which counts the number of reclosing, number of operation of the reclosure, and if the corresponding current through this branch is high, then the sectionalizer, you can say that, opens this circuit when the reclosure was in the open condition. So, that successfully, you can say that, isolates this portion and thereby the rest of the consider that section, the rest of the network can be still you can say that remain intact. So, this in addition to that, there can be considered in the protection scheme also and fault location perspective, which can pinpoint that where the fault has occurred, and accordingly you consider the maintenance crew can be you can consider that restore the service you can say that at early as possible. So, we through this lesson we see that what are the different elements of a protection scheme, what are their features, and the selectivity, reliability, zones of protection, and so in terms of that. In the next lesson, we will address on the review on the fault analysis, which will be very useful in developing the different relaying principle also. Thank you.